Some limits cannot be found using algebraic methods. If direct substitution produces 0 over 0, infinity over infinity, or negative infinity over negative infinity, then L'Hopital's rule may help. L'Hopital's rule says that the limit as x approaches c of the numerator over the denominator, some function over another function, is equal to the limit as x approaches c of the numerator's derivative over the denominator's derivative. For the AP test, if you're using L'Hopital's rule on the free response, you must show that the limit of the numerator is equal to the limit of the denominator. You cannot just direct substitute. You should never actually write these indeterminates. That's why you need to separate the numerator and the denominator to show that they both approach 0, they both approach infinity, or they both approach negative infinity. To use L'Hopital's rule, you need the limit of an expression written in fractional form. Example 1. I can eyeball that if I plug in infinity into the top and the bottom, we're going to get infinity over infinity. But I shouldn't actually write any indeterminate forms on my paper. AP does not like that. Instead, I consider the limit of the numerator and the limit of the denominator separately. I already figured out that the numerator's limit will be infinity as well as the denominator's limit, and I've proved that separately. So now I'm going to derive the numerator. I'll call that f prime of x. The derivative of x is 1, and then derive the denominator. The derivative of e to the x is e to the x. L'Hopital's rule states that I can now take the limit of the numerator's derivative over the denominator's derivative, and it will give me an equivalent limit. This time when we direct substitute, we get 1 over infinity, which is essentially 0. Number 2 is very much like number 1. We have to show the limit of the numerator separate from the limit of the denominator. That's infinity. We'll derive the numerator and call that f prime of x. Derive the denominator and call that g prime of x. So by L'Hopital's rule, we can take the limit of the derivatives of the numerator and the denominator. By direct substitution, we get e to the infinity, which is infinity. Remember, infinity is not a limit, it is simply a direction. But if your direction is infinity or negative infinity, you should always write that rather than does not exist. Do you notice that for number 3, when you direct substitute, you do not get an indeterminate form? 0 over e to the 0 is 0 over 1, which is 0. For number 4, if I direct substitute 0, I'm going to get something that's undefined. But notice how this is a one-sided limit. I could actually plug in really tiny numbers that are to the left of 0 and see what this is approaching. Because I know that 0 is a vertical asymptote, the result for number 4's limit will be infinity or negative infinity. I'm going to begin by plugging in negative 1 over 10. You could also plug in negative 1 over 100, but as you could see, you would get negative 100 divided by e to the 1 over 100, and that would be getting more and more negative. So this limit is approaching negative infinity. Do not use L'Hopital's rule just because a problem looks like a candidate for the rule. Examples 3 and 4 are not candidates for L'Hopital's rule because direct substitution does not produce an indeterminate form, such as 0 over 0, infinity over infinity, or negative infinity over negative infinity. If using L'Hopital's rule leaves you with one of those indeterminate forms, then you can use the rule again. It is a process which can be repeated as many times as necessary. Ooh, that sounds fun. Just remember to use direct substitution at every step to make sure the rule can be used. And show that direct substitution for the numerator and denominator separately for AP. First, I'll show the limits of the numerator and denominator separately. Zero over 0 is indeterminate, so let's derive. Now by L'Hopital's rule, the limit will be equivalent to the limit of the derivatives. Negative 9 is your answer. Uh-oh, this is not in fractional form. so I can't use L'Hopital's rule. But if I direct substitute, I get e to the negative infinity times negative infinity squared, and I don't know what that is either. So I'm going to use the property of exponents to rewrite the expression inside of the limit as a fraction. X squared over e to the negative x. Now let's show the limits of the numerator and denominator separately. That is essentially positive infinity and positive infinity. So let's derive. If you direct substitute, oh look, we have an indeterminate form again. So let's use L'Hopital's rule again. So let's derive again. And with L'Hopital's rule, direct substitution gives us 2 over infinity, which is essentially 0. When I substitute 1 in my head, we get 0 in the numerator and 0 in the denominator. So let's show those limits separately and use L'Hopital's rule. Derive. Try out L'Hopital's rule. And direct substitution is going to give us 0 over 0 again. Let's show those limits. Derive again. This would be x to the negative 1. With direct substitution, our result is negative 1/2. You will see 2 acceptable spellings for L'Hopital. First is the O with the circumflex accent on top. This version does not have an S in it, but O with a circumflex is no longer used in French, so OS has taken its place to give the O sound. Even though the second version has an S, it is silent.